In this video, we will demonstrate the use of SciFinder's sequence search capabilities for CDRs. CDRs are complementary determining regions that are part of antibodies. We see here the growing application of antibody drug conjugates in the patent literature in SciFinder. Very often, these patents define antibody drug conjugates as three different components, one being the antibody, the linker, and the U in this case represents the cytotoxic molecule. If we look at an earlier part of the patent, we would see that the CDRs have been identified as sequences. We can use SciFinder's sequence search capabilities to determine if there are similar definitions in patents of antibodies and their CDRs to retrieve possible prior art. For that, we will log into SciFinder, go to the sequence button, and here we have three options for BLAST, CDR, and motif. We will use the CDR. CDRs are short stretches of amino acids which are highly variable. They are responsible for the binding regions of an antibody. And each chain of an antibody or T-cell receptor has three CDRs. So that's why we have three search boxes for them. The CDR searches in a part of the database where sequences have been identified either as antibodies or T-cell receptors. Let's bring these three CDRs into our search box. So after entering the three CDRs, we can decide to include also sequences from the NCBI source or start the sequence search. The sequence search will run here, and we see that the search has been completed very quickly and open up the results. The sequence search in SciFinder brings back 100,000 results that are visualized in this Venn diagram for those sequences that include all three or only two or just a single CDR in the antibody or T-cell receptor that was created. We will focus on those that have all CDR components. We now retrieve 11 results that can be sorted either by alignment, e-value, query coverage, or subject coverage. Here we see where the three CDRs have matched either a light chain or heavy chain part of an antibody. We see the alignment, which is 100%. We can check that up here. In the tab for subject, we will see the total definition of the antibody. We can see this is a synthetic construct. There are also several registry numbers for these sequences. In the reference tab, we'll find the latest patents as well as journal articles for this particular answer. We can get to the references just for this sequence by clicking this reference button. Further down, we will also see that there are answers where the sequence did not have 100% alignment identity. Here we see that other amino acids have been reported in the subject, but still close answers like these can be retrieved quite easily. They would have their own specific patent and possible non-patent literature references. We go further back to the top. We do have some additional filtering capability, particular for sequence length. Here we do see that the length is in a range that would actually match the light chain component of an antibody. But we could, if we want, filter by that. Could also indicate that the alignment would have to be higher than the 90% that we potentially want. Otherwise, we can also look for all of the patent references for all 11 answers by clicking the reference button here at the top. This will export all of the patent numbers retrieved for all 11 sequences and group them by family and report them back into the SciFinder interface. We see that the 11 answers were retrieved in 25 patent families. In order to combine the CDR sequence result with a structure search for the toxin, we can save this answer for later use. We click here at the top right on the Save button, give it a name, save it, and now we are ready to start the second part of our search, which will define the toxin. Go back to the landing page of SciFinder, go to Substances, and here I would be interested in finding derivatives of a specific toxin called MMAE. You can see that there's a variety of names available. We'll search for it. We see that we do retrieve the compound itself. I'll click on the structure, click on Edit Structure to put it into the structure editor. Make that a little bit larger. And in order to retrieve also further variations, I'm going to remove these two substituents and leave them open for any type of substitution at that particular point. Can, if prefer to, also flatten the stereochemistry of the toxin for a more complete retrieval. Click on OK and run the structure search. For the structure search, we see that there are two exact match, but we are more interested in the 5,500 substructure search answers, where potentially additional linkers could be defined to connect the MMAE or other derivatives to the antibody. So we have now completed our structure search with several variations that could exist here. We'll look for the references for these substances, finding almost 3,000 references, including a good number of patents. Here we're going to use the Venn diagram icon to do a combination with our previously saved answer set. We'll use intersect, select the 25 patents we retrieved from the CDR search, and simply click on View Results. We now retrieve 5 results that have the combination of our CDR for the antibody as well as the small molecule or its variation that we desired. We see that we got fairly recent patents, and if we look at the organizations, we see that Remagen as well as Seagen are the two companies competing in this particular area.